Okay, this is the remaining problems from section 3.6 of our quadratic function section. We learned in class this past week that this is called the standard form of a quadratic. In other words, ax squared plus bx plus c. And that form is really good for factoring or solving the quadratic formula. It's also not a horrible form to graph in if you know the shortcut formula for vertex, which we did learn. But if you put your function into this vertex form down here, a times x minus h squared plus k, then you have the vertex staring at you right away. It's the opposite of h and k. So you can get your vertex immediately if you do have it in transformational form. So that's what we kind of spend most of our time on. So this would be hk for the vertex. So what we want to do now is we spent a good deal of our time on the class session where we covered this, showing you how to take standard form and go into completing the square to turn it into vertex form. But we didn't get to spend as much time going the opposite way. So we did one example, example 2 of doing it the opposite way, and I wanted to, and one of my classes did B as well, but I'm going to do from B on, just showing you how to take some random information about a quadratic, usually including the vertex, and to turn that back into standard form using the formula for vertex form. So our formula for vertex form, remember, is f of x equals a parentheses x minus h squared plus k. And we're going to treat this as if it's kind of like point slope for quadratics. It's something we can plug information into and find missing pieces. So notice they gave us the vertex, which is h and k, and a second point, which you can think of as a generic x and y, except remember y stands for f of x. So we're plugging it in and we're going to solve for a. So f of x would be 3. We don't know a. X is 2, because I'm looking at my list, minus h, minus a negative 1, so that's going to end up being plus plus, squared, plus k, which ends up being a negative 2. So we go ahead and add inside that parentheses, and then I would square the 3, so that's going to be 9a, and this is just minus 2 if I want to drop the plus a negative. I would add the 2 over, make that 5, and then divide by 9. So notice this time my a is a 5/9. Once you have a, h, and k, then we can plug back into our vertex form, which is above us right here, to get to standard, which is what our directions asked for. So let's take what we know. Okay, so h is negative 1, k is negative 2, and this is 5/9. So now we write f of x equals, and that would be 5/9 x minus negative 1, which would be plus 1 squared, minus 2. Okay, so to work this out, we would need to FOIL out x plus 1 squared. And then after we do that, we'll have to distribute the 5/9 to all of that. So this ends up being 5/9 times, if I FOIL this out, that would be x squared plus 1x plus 1x, that'd be plus 2x plus 1 times 1 is 1, and then the minus 2 at the end. But we have to distribute the 5/9. That'd be 5/9 x squared. When you distribute to a fraction to another number, you multiply top times top, bottom times bottom. So this is 2 over 1, so that would be plus 10 over 9 x. 5/9 times 1 would just be 5/9. And I'm going to go ahead and write this minus 2 over 1 because we're going to need a common denominator to finish this off. So I'll multiply that by 9 over 9. So this is 5/9 x squared. That's supposed to be a plus 10/9 x, and that would be 18 over 9. So 5 minus 18 would be negative 13/9. So there that quadratic would be in standard form. It's a pretty messy one because the a is a fraction. Now we would never give you something like that on the exam, and in fact we don't give you any from this specific example set on the exam. You need to know how to transform to vertex form using completing the square, and of course you need to know how to graph, but these do show up in the homework. So let's do another one. This one has a vertex of 0, 5, so that's my h and my k. And this is x and f of x. So this would be finding a first, so -3 equals, we don't know a, x would be 2 minus h squared plus k. So that's -3 equals a times 2 squared plus 5. That would be 4a plus 5. Subtract over the 5, we get -8 equals 4a. So -2 is a. So this one should work a little quicker because we didn't get a fraction for a. So I take my a, my h, and my k, remember to plug back in. So f of x equals -2 parentheses x minus 0 squared plus 5. X minus 0 though is just x. So this is just x squared. So there is nothing else to do there because x squared doesn't need to be FOILed out, it's just x. So that one actually went pretty quick. For this, make sure you write the x-intercept as an ordered pair first. So here's my h, my k, my x, and my f of x. So this is 0 equals, we don't know a, x is -4 minus h, which is 4, squared plus k, which would be -7. That is -8 squared plus -7. I think I'm going to need more room on this one. Excuse me. And then we would work out the 8 squared, which is 64. A minus 7, add the 7 over, and then divide by 64. Now, we're not going to give you a nasty fraction one, so I'm not going to FOIL this one all the way out like I've been doing the others. Let's just write this in vertex form only. So this would be f of x equals 7 over 64, x minus 4 squared minus 7. Of course, if we wanted to work this out, we would have to FOIL that and then distribute the 7 over 64. The one I do want to do that's a little bit different and might show up in your homework is this situation right here. So this one doesn't give us the vertex at all. So notice we don't have the vertex in front of us. It says you have x-intercepts of positive 8 and 0, and your lowest point, which is your vertex. We do know one thing about our vertex, because it's either the lowest or highest point on a parabola, has a y-coordinate of -48. So we're missing the x part of our vertex. We don't know what it is. We don't know h. But if you think about a parabola, and let's just draw a picture. Here's 0, 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. When you're talking about a parabola, if you cross the x-axis twice, the vertex should be dead in the middle of those x values. So look, 1, 2, 3, 4, over 1, 2, 3, 4. This is going to be the vertex x value because it has to be equally spaced from the other ones. Of course, it's going to be way down here, but that's where it's going to happen for x. So this is going to end up being 4, -48. So even though it didn't look like we had the vertex, we had enough information to find the rest of the vertex. So I now have my h and my k, and I can use either one of these ordered pairs. I'm going to use 0, 0 because that's really nice to plug in since that's one of my x-intercepts. So we would go with f of x equals a parentheses x, which is 0, minus h squared plus k. So 0 equals, that's going to end up being -4 squared, so that's going to be 16a minus 48. Add the 48 over, divide by 16, and we get 3. So this one, since it's a nice number, we'll go ahead and work it all the way out. So this would be f of x equals 3 parentheses x minus 4 squared minus 48. We'll FOIL out that x minus 4. That would be x squared minus 4x, so that'd be minus 8x. Negative 4 times negative 4 would be positive 16. We distribute the 3. And notice at the end, our 48s are going to cancel out because they're opposite signs. So my final answer on this one is just 3x squared minus 24x. So that is how you take general information about a parabola like the vertex and a second point, and you can turn it into vertex form by finding A, and then turn that into standard form by simplifying. So then our next topic is to finish off some of these graphing ones that we did. We did one at least together in both classes. I'm going to do the rest of them. We said that there is a shortcut to finding the vertex if you don't want to have to go through the mess of, turning it into a parentheses x minus h squared plus k. The formula that we learned that helps us find the vertex is that if you want to find your vertex from standard form, so if you're in this form right here, you take x equals negative b over 2a to find the x coordinate of that, so that'll be our h, and then you plug that back into the function to find your y coordinate. So that's how you find your k. We also learned that we could find our X-intercepts and Y intercepts. Remember, that's just plugging in 0 for one letter at a time. And we could determine if the parabola opens up or down depending on if the leading coefficient was positive or negative. And then we also said the axis of symmetry, the point that splits the parabola in half, that vertical line, is always the x equals negative b over 2a. So that's kind of what we discussed in class. So we're going to look at a couple more examples of graphing to finish out section 3.6. So let's look at this one right here. So notice that we would start out with asking, does it open up or down? That just gives you an idea of what the graph's picture is going to look like. Since A is positive or greater than 0, 6 is bigger than 0, it's a positive number, that means we open up. So our parabola should look like this. If we find the vertex, we use our formula. So we're going to get an ordered pair for this. So x equals negative b over 2a. That's negative 7 over 12. So notice not always does the vertex come out to a nice number. Then we have to plug that in to the function to find the y value. Now just FYI, the one we give you on the test does have a nice vertex. But this is just to show you that things don't always behave. So I'm going to use my calculator to help me evaluate this. So this is going to be 49 over 144 because I'm squaring both of those. This will be negative 49 over 12. I need to multiply that 49 times 6. So that's 294 over 144. I need to go ahead and get a common denominator for these two. And we'll do the last one in a minute as well. So 49 times 12. You could just type this all into your calculator if you have a scientific calculator, but I don't on my computer. This does not really do inline points. And then we need to multiply the last guy by 144 on top and bottom so that it has the same denominator as the others. So 24 times 144 is 3,456. So minus 3,456 over 144. All right, so across the top, that's 294 minus 588 minus 3,456. That's negative 3,750 all over 144. Now, just to give us an idea of what that's going to be like, it's going to be about negative 26. So this is a pretty low down vertex. We're not going to be able to graph it on this picture. So we may not actually graph this one because it's going to end up pretty messy, but I want to at least show you how to find all the pieces. So 3,750, we can reduce this by dividing by at least maybe 4, nope, by 2. That's 1875 over 72. That's probably about as good as that's going to get. And that's negative. So we already know that this is going to be a really hard thing to plot. So let's just go ahead and finish out the rest of the information. And like I said, we won't graph this one since this is not a level of difficulty that you're expected to be able to graph. Okay, so let's, excuse me, it's not wanting to stay. Let's look at the intercepts next. So notice that the y-intercept's always easier to find. So this is all for the vertex. For the y-intercept, you just plug in 0 for all the x's, and it's going to be 0 comma something. So that would be 6 times 0 squared plus 7 times 0 minus 24. So it ends up just being negative 24, which is pretty close to that negative 26 we see in the vertex. For the x-intercepts, though, you have to actually set it equal to 0. And we don't know if there will be 1 or 2 or none. We have to check that out. I'm going to go ahead and move this other one down. So when you're trying to solve for the x-intercepts, you let this equal 0. And you could try to factor, but I wouldn't waste time if the numbers look pretty big. I would just go ahead and jump right into quadratic formula. -7 plus or minus square root of 7 squared minus 4ac all over 2a. If it comes out to a nice number, great. If not, we didn't waste time trying to factor. So 49, well, let me go ahead and figure out this. So this is -4 times 6 times -24. So this is going to be 49 plus 576 inside that radical, because the two negatives make a positive. So add 49 to this, and that's 625, which I do believe is a perfect square. Let's see if we can take the square root of that. Yep, it's 25. So see, this would have factored, but we didn't waste the time factoring if we jumped straight into the formula. And I always do that if they look really complicated to factor. So this would be -7 plus 25 over 12 and -7 minus 25 over 12. So 25 minus 7, and then so that'd be 18 over 12. We can reduce that down. Divide them both by 6, that would be 3/2. So one of my x-intercepts is 3/2 comma 0. Add these together, 25 and 7, but it'll be negative, so that'd be -32 over 12, and divide both of those by 4, that'd be -8 over 3. So again, not the fun plots that you want to do because they're fractions, but at least they came out to nice numbers. So there's my y-intercept, there's my vertex, I open up, and there's my x-intercepts. The only other thing we'd want to write before graphing, if we were going to graph, because I'm not going to on this one, is the axis of symmetry. And that's just x equals the x value of the vertex, so -7 over 12. But you do need to write it as an equation because the axis of symmetry is a vertical line. So again, if we wanted to plot this one, and I don't want to stress this too much because on the test we would never give you anything with such crazy fractions to plot. But you'd have to convert most of these to decimals to get an approximation of where they need to be plotted. All right, let's do another one. So this one, C, is -4x squared plus 4x minus 1. So it opens down because it has a negative in front of its leading coefficient. The vertex is going to be an ordered pair. X equals negative b over 2a. That's negative 4 over negative 8, or 1/2. A little bit nicer of a fraction. So we plug in 1/2 to find the y value. Square that would be 1 times 1 and 2 times 2, so that would be 1/4. 4 cut in half would be 2. 4 and 4 cancel here, so that just leaves me -1. This actually ends up being 0. So our vertex is actually an X-intercept. Now, interesting thing to note, if your parabola touches the x-axis, and this one's supposed to be opening down, it can only touch the x-axis once if it's the vertex. So I will show you how to find the x-intercept in a minute, but if the vertex ever is an x-intercept, it's the only one you're going to have. But we do have a y-intercept. So let's plug in the y-intercept is f of 0, so 0 for x to find y. So -4 times 0 squared plus 4 times 0 minus 1. So it looks like it's just -1. If I didn't notice that the vertex was an x-intercept, I would try factoring this one. It's not too bad to factor. Or you could do quadratic formula. If you want to factor it, you would pull out a -1 at the beginning because we don't like our leading term to be negative. That does change all of your signs though. So 4 times 1 is 4. Factors of 4 that make -4 would have to be -2 and -2. So that would be 4x squared minus 2x plus 1 to factor by grouping. And we pull out a 2x in the first pair. That leaves us with 2x minus 1. We pull a -1 out of the second pair. That also leaves us with 2x minus 1. So this factors into 2x minus 1 was the match, and 2x minus 1 is the leftovers out front, which means you only need to solve it once. So it's 1/2, which is what we got earlier. We already knew that the vertex was the x-intercept because it has a 0 for y. Our axis of symmetry would just be x equals 1/2 because that is the vertex x. Okay, so if we plot this one, 1/2 0 is right there. Then we'd have 0, -1. Now that's only 2 points, but the nice thing is if you have the axis of symmetry, which is 1/2 as well, there's a mirror image point on each side. So, oops, I want to erase that, but it's not going to let me. Just ignore that little string right there. This is a kind of narrow, skinny parabola. If I didn't like that I didn't have another point, you could always evaluate like f of 2 or f of -2 or something like that to get more points. But as long as you have enough idea, at least vertex and then 2 points on each side using symmetry, that should be enough to get the graph. All right, we have 2 more graphing ones and then we'll be done with 3.6. So notice this one has a negative out front, -3x squared minus 6x minus 6. So it's going to open down. For the vertex, x equals -b, which would be -6, that's +6, over 2a. 6 over -6 is -1. Plug that back in to find the y, part of the vertex. -1 squared is 1. Negative times negative here is positive. So this is -3 plus 6 minus 6, which means it's just -3. So there's my vertex. For my y-intercept, plug in 0 for x. So f of 0 equals -3 times 0 squared minus 6 times 0 minus 6. That just ends up being -6. Notice it's always the constant when you're in standard form. For X-intercepts, I already know that this one's not going to have any, and I'll show you why. This is -1, -3. That's my vertex. My y-intercept is here. This parabola opens down. It's never going to cross the x-axis, but let's show you how do you know that from the process. If you set this equal to 0, let's say we want to use quadratic formula to solve it. Just go as our go-to. So x equals -b plus or minus square root b squared minus 4ac all over 2a. This is 36. Negative times negative would be positive 12, but that makes that -72. You're going to get a negative underneath your radical. It's going to be -36, which means this is imaginary. Imaginary numbers are not x-intercepts. They're not on this graph at all because we don't plot imaginary numbers on the number line, we plot real numbers. So there are none. So anytime you're doing one of these problems, if there ends up being a negative underneath the square root, that means you have no x-intercepts. Our axis of symmetry is just x equals -1. Now, because notice this is the vertex, if you go over 1 and then down 1, 2, 3, that's where this point is. So if we go over 1 and down 1, 2, 3, there should be a mirror point. That's what the axis of symmetry tells us. So wherever your vertex is, there's equal distance points on each side. And then the final graphing problem. This one is going to open up because it has a positive in front of x squared. The vertex, x equals -b over 2a, so that's 4 over 4, which is 1. Then we plug that in to find our y part of that. That is 2 minus 4 minus 11. It's going to be -13, so a little bit below my graph, but we can make that work. So it's 1, -13. Our y-intercept, if you're kind of getting the pattern now, it's just the number at the end, so it's going to be 0, -11. Our x-intercepts, if we have them, so let's plug this into the formula for quadratic. So x equals -b plus or minus square root b squared minus 4ac all over 2a. So that's 4 plus or minus the square root of 16 plus 88 all over 4. So 16 plus 88 is 104, which I believe has a perfect square in it of 4. Yep, 4 times 26. So this would be 4 plus or minus the square root of 4 would be 2. We'd still have the 26 inside. So what I did there, remember, is I broke 104 down into square root of 4 and square root of 26. So square root of 4 is 2, and then this reduces. So that would be everything reduces by 2. So that would be 2 plus or minus square root of 26 over 2. Now that means both of my x-intercepts are nasty decimals. So this is one of them, and the other one is when we add that. So there are my x-intercepts. You just use this number once with the minus and once with the plus. Now obviously we're not going to graph it with those nasty things. We're going to get an approximation. So 26, take the square root of that, make it negative because I need to work backwards on my calculator. Normally you would just type this in from left to right, plus the 2 that was up front, and then divide it by 2. So my first one is -1.5-ish. So my x-intercepts are approximately -1.5, 0, and square root of 26 plus 2 divided by 2 is 3.5. So negative 1.5-ish and 3.5. Here's my two X-intercepts. And then 0, negative 11 is going to be about down here. And then 1, negative 13 is going to be a little bit farther down. Now the one we give you on the test will always fall within our graph range, but it is possible for them to be bigger and smaller than negative 10 to 10. So this is the final one, but notice that this one was one I wanted to show you because you got nasty intercepts that are real numbers. They are numbers. They're just something you have to work out an approximation for. So that's all the variety of graphing. If you were studying for the test, the two that I would pay the most attention to in terms of what would you expect to see, possibly A, the one we did in class because it factored nicely and had a nice vertex. C is a good option because it factors nicely, has a nice vertex. I wouldn't expect one with the imaginary numbers or the nasty fractions, but you could have a trinomial that factors, so don't rule out having just a trinomial that factors nicely. And that's it for 3.6.